Hi, I'm an old guy and I do maths, and we have some questions. The first question is, what does this mean? And by this I refer to, in fact, these, but they are all the same. So what does this mean? Well, let's answer that before we get into this. So what ax squared means, ax squared, it means this. It means a times, we'll put that little dot there for times, x times x. So it is the x that is getting squared. So if we refer to the order of operations in mathematics, that's probably the best explanation for this. This 2 is above the x, and it tells us to square this. The a is beside the x, and it tells us to multiply whatever is here. Now the order of operations tells us that we do this first and then we do this. So it's hopefully not a matter of confusion for you if you think about the order of operations. Now let's take this 2x squared. Sometimes it's easier to look at numbers than letters. Well, this is 2 times x, the same thing. 3x squared, 3 times x. Now you'll see that in each case there is exactly the same pattern. The fact that there's a letter here, a pronumeral, means nothing. There is no difference mathematically between the way in which you address any one of these three expressions. Okay, so what this means is that. What this means is that. What this means is that. A times x squared. 2 times x squared. 3 times x squared. Now, what about this? Again, by which I mean this type of expression. Let's have a look at that. So we have ax in brackets all squared. Now there's the clue, all squared. That's just a manner of speaking, and it's something that I've picked up over the years. Let's just take that out of the mix for the moment and say this is ax squared. You'd say it the same way as that. You could say ax squared, and someone listening to you wouldn't know that there was any difference or that you were talking about two different things, but in fact we are. What is in this bracket is an expression ax, and we have been told by this little index here to multiply this bracket by itself. So that is ax times ax. So what we wind up with here is a times a, which is a squared, x squared. Let's write that a little more clearly. Okay, now what are the consequences of that for these two expressions here? Well, 2x in brackets squared is 2x times 2x, and that gives us 2 squared x squared, which gives us 4x squared. And you can immediately see the difference between what's going on here and what's going on here, I hope. They're fundamentally different. And they're fundamentally different because of the use of these brackets. Everything that is in these brackets gets squared. The case up here, if you can still see this in the frame, yes, I've just checked the camera, it's only the x that's getting squared, and it will hopefully be a little more obvious to you now that that's what's going on. So just to complete the series, 3x squared, that is 3x times 3x, so that is that times that, which is 9, we'll do this the long way, 3 squared x squared, which equals 9x squared. So the reason for including this is that nobody thinks that this is times. It is 2 times 2, yes, The problem with 2 squared is that it is the same as 2 times 2. So I like to use examples where it's obvious that this is, for instance, not 3 times 2, because 3 times 2 would be 6, and the answer is 9. So let's just review this quickly and extract whatever rules we can. The order of operations in mathematics tells us that we should square the x and multiply it by 2. The order of operations in mathematics tells us that because these are in brackets and they are together, we treat them as such and we square everything in that bracket. The net result is that for the first ones we have a times x, and for the second we have ax squared times ax squared, or a squared times x squared, which is what we have here. And because we have numerals here, we can write this in a more coherent and recognizable way. So 2 squared times x squared gives us 4x squared, 3 squared times x squared gives us 9x squared. I hope this was helpful and cleared up some confusion. There'll be in the playlist, this is in the indices and exponents playlist, I think. It's in the indices playlist anyway. There'll be other examples like this. So, for instance, how do we treat negatives when we've got exponents and that sort of thing. Have a look at them all. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.